Good evening all of you, and here is a good and relevant problem for upcoming JEE Advanced. Since JEE Advanced has already tested a similar idea, so let's see how to solve this problem. We have expression P which goes from summation I equals 1 to 10, 1 by 1 plus I over 10 root 3 whole square. A similar expression is Q. If you'll see carefully, the only difference is in the limit of summation. So in the second case, it got from 0 to 9. In the first case, is 1 to 10. And we have following beautiful options. It's multiple correct choice. P less than Q, P is less than pi over 6Q, P plus Q is less than pi by 3 or more than pi by 3. So out of these following choice, we need to tick one of them. Now before you go and start the problem even, you can clearly see P and Q has some pi by 6 connection. So if I'll use the telescopic idea, or if I'll use any sandwich idea, definitely it will not give birth to pi, because algebraic manipulations will still remain algebraic. So the usual thought process will be to connect with the integration. As you can see, the function that I am going to mimic is 1 by 1 plus something whole square. So let's call f of x equals 1 by 1 plus x square. And very beautifully, you can draw the graph. You can check its derivative also is minus 2x over 1 plus x square whole square, means function is strictly decreasing. A derivative die at x equal to 0, so the function is differentiable at every point. Moreover, we are only interested in the positive x-axis. So if I'll put, let's decode the sum p. If I'll keep I equals 0, I equals 1, I equals 2, we'll have expression like 0, 1 by 10 root 3, 2 by 10 root 3, till 10 by 10 root 3. So graphically you can see, if I put I equals 1, I'll get 1 by 10 root 3, which means corresponding to this height, the function value is going to be 1 by 1 plus 1 by 10 root 3 whole square. That is precisely the value of the expression at I equals 1. Similarly, at I equals 2, we'll get this height. Okay. Now I can treat this I equals 1 value as nothing but the area of this small rectangle. Because if I'll keep I equals 1, I'll get 1 by 10 root 3 and f of 1 by 10 root 3. So I can pretend as if it's length into width. So the first expression shows area of this part. Similarly, we have second expression. And the last expression, which is 10 by 10 root 3, shows area of this part. This is small chunks. As you can clearly see from the nature of the curve, if I'll add all these smaller chunks of rectangle, this will definitely be lesser than the area of the curve bounded from 0 to 10 by 10 root 3. And that's what I've shown here. So that shows the p value will definitely be lesser than pi by 6. Exactly in the same manner from 0 to 9, now you can play with the trick. So this time f of 0 will represent this height. So f of 0 times 1 by 10 root 3 is nothing but the area of this chunk, as you can see in this silent part. Same goes with the another chunk, f of 1 times 1 by 10 root 3. F of 9 times 10 root 3, I can move ahead from 9 to 1 by root 3, means 1 by root 3 is 10 by 10 root 3. So this time if I'll add the area, clearly we are overestimating the area under the curve. So from here 0 to 1 by root 3, if I'll add this chunk, right, 0 to 1 by root 3, if I'll add this chunk, we have area f0 times this, f1 times this, and f of 9 by 10 root 3 times the gapping width, which is constant here. This gapping, the width of rectangle is fixed as 1 by 10 root 3. तो यहाँ से I'll get Q is more than pi by 6. वो आप clearly यहाँ से देख सकते हो, because Q is the area bounded from 0 to 1 by root 3, which is 10 by 10 root 3, and that is more than, clearly Q, the area bounded by this rectangle, is more than the area under the integral umbrella. So Q is more than pi by 6. The last interesting part is more exciting, and it shows like what will be the addition. Now directly we can't conclude, because if P is less than pi over 6 and Q is more than pi over 6, so we can't conclude about P plus Q directly with intuition. So it may be less than pi over 3, it may be more than pi over 3, that depends on their relative magnitude. Okay, so one way of looking at this is, if we'll see P plus Q, we have I equals 1 to 9 is already repeated. So we have P plus Q will give basically f of 0, which is coming from Q, plus 2 times of f of 1 plus 2 times of f of 2, and this will go till 2 times of f of 9 because f of 9 only contributed from p and q both, and plus f of 10. And this is an exciting summation. So this time again I'll do area bounded, but instead of taking rectangles, what I have done is I've taken trapezoid. Why that logic came? Because you see the area of trapezium will be half into sum of parallel sides into height. Well, let's see, UV is the length of parallel sides. So again, if we'll put this on the graph, let's say 0 to 10 by 10 root 3. Now since the nature of the curve is aesthetically decreasing, okay, and you can see the concavity is like this. So if I take up, let's say, any 2 point P and Q on the curve, that you can do with the double derivative f dash x again to understand the concavity in a more intuitive way. So if I'll join P and Q, so clearly you can see the chord P and Q is always above this chunk PQ. Okay, that is because you can see clearly it's convex down, like because it's opening concave up. So from this logic, what I can tell, the area under this curve will definitely be lesser than the area of trapezium formed by PQ and RS, and that's the underlying logic here. Now what is area of this PQ and let's say origin if I'm telling RS? So area for this chunk of trapezium is more than the area under the curve. So that is half into sum of parallel sides into height. So this will become half into f0 plus f of 1 over 10 by root 3, and height is fixed to 1 by 10 root 3. That is the first portion. Again, if I add the second portion, you can see it will contribute like this, and the last portion will give f of 9 over 10 by root 3 plus f of 10 over 10 by root 3. अब इस सबको अगर हम ऐड कर देंगे तो आप अभी देख सकते हो दिस समेशन विल डेफिनेटली बी लेसर देन dx by 1 plus x squared 0 to 1 by 3, और इसका वैल्यू pi by 6 है. But we needed p plus q. So what is p plus q? As we have seen is f0 till this by 10 root 3, but we have found f0 by 20 root 3, so 10 root 3 will give pi by 3. So from here what we can conclude is p plus q is less than pi by 3. So this was also a beautiful way of getting the answer. So the final answer that I got is p is less than q, p is less than pi by 6 and q is more than pi by 6, and p plus q is still less than pi by 3. Now the first two-part question was already hinted in JEE advanced paper before, but C part is a new creation here, and you can see how beautifully we can use and exploit trapezial idea also using the concavity of the curve to derive more fundamental results.